The Diels Alder reaction is one of the most useful and efficient reactions in organic chemistry, especially for making six-membered rings. A 1,3 conjugated diene is treated with an unsaturated partner molecule known as a dienophile, usually at high temperature in an appropriate solvent. The result is a six-membered ring that is formed through a concerted cycloaddition process. The reaction is known to be stereospecific, which suggests a concerted pathway in which all bonds are formed and broken at the same time on the way to the product. The accepted mechanism involves the frontier orbitals of the diene overlapping with the pi bond of the dienophile and passage through a 6-electron transition state as shown. The required orbital overlap is obvious in the enhanced picture of the transition state shown. The diene and dienophile are able to interact in such a way that electron density flows in a logical manner that avoids the formation of any intermediates. In order to react this way, the diene must be in the S-cis conformation so that the frontier orbitals are both pointing towards the appropriate orbitals on the dienophile. The fact that the Diels Alder reaction is a stereospecific process is highlighted here. The cis stereochemistry of the dienophile is retained in the cycloadduct product, which indicates a concerted process. If an intermediate such as a carbocation or radical was formed, there would be the possibility of single bond rotation and loss of stereochemical integrity. An additional aspect of the Diels Alder cycloaddition is the consequence of using a cyclic diene. These molecules are trapped in the S-cis conformation, which is an advantage. However, the bridging CH2 group in the cycle adds an extra complication to the possible outcomes of the cycloaddition. Two stereoisomers are now possible, the exo and endo cycloadducts, with the endo isomer usually being favored due to secondary orbital overlap effects in the transition state leading to that product. When a conjugated diene is treated with a dienophile pi system, a concerted cycloaddition known as the Diels Alder reaction occurs and a six-membered ring is formed. The reaction is stereospecific and concerted, which allows for prediction of the product structure when the method is employed in complex molecule synthesis.